What would you think if I told you that there is a frozen galaxy moving through space like a live fossil? The James Webb Space Telescope has now found a live galaxy fossil that has been lost for billions of years. Even though it hasn't made any new stars in billions of years, this galaxy is still there. What does this interesting cosmic event have to do with? A fossil galaxy is one that has mostly older stars and hasn't made any new stars in billions of years. In the field of astronomy, fossil galaxies are thought to be leftovers from the very beginning of the universe. They give scientists interesting information about how galaxies have changed over time and how things changed in the very beginning of the universe. These interesting ancient galaxies are usually found in the middle of large groups of galaxies. They may have been left over when the groups of galaxies merged. Still, these strange galaxies make us wonder. Why did some galaxies freeze and almost stop growing so soon after they were formed? And why are these galaxies still busy in their own way? Since the beginning of the universe, these galaxies' shapes and makeup haven't changed much. This means that they are witnesses to a time when we don't know much. The James Webb Project should finally give us useful information about the universe's early past. Since the telescope was first put into space, it has surprised us many times. It keeps showing us amazing science things, and the list of things it finds in space keeps growing. We still don't fully understand how and why galaxies formed, and we don't fully understand why galaxies have been getting closer together over time. At the moment, scientists are looking at very old, faraway galaxies that were formed in the very beginning of the universe in order to finally figure out how matter evolved. With its new find of the dinosaur galaxy, the James Webb Telescope has added another unique find to its list. The galaxy formed very early, very well, and spread out very far. It went through evolutionary steps that normally take billions of years in a very short amount of time. A starburst is what scientists and cosmologists call this sudden burst of star formation. In a very short time, the galaxy made billions of stars, which formed a beautiful spiral shape. After that, the galaxy's star production pretty much stopped. It hasn't changed much since then. Scientists think it's a miracle that these beautiful galaxies are still around even though star formation has stopped. This is likely because of how gases are distributed and the effect of dark matter and dark energy. It is very unusual for a galaxy to become a fossil so early in the history of the universe. Scientists still don't fully understand how dark matter and dark energy affect the formation of visible matter and galaxies, so they can't say for sure what fossil galaxies are made of or how they move. This is shown by the galaxy fossil NGC 1277 in the Perseus galaxy cluster. Isn't it amazing that we can study things millions or even billions of light years away with tools like the James Webb Space Telescope? The infrared spectrometers on the James Webb Space Telescope make it possible to see light at wavelengths that our eyes can't see. Webb finds the faintest bits of light and turns them into pictures that we can see. This technology has made it possible for scientists to see through clouds of space dust for the first time. There is a lot of cosmic dust in the universe, and all matter and galaxies are made up of dust and gases in the end. There is a lot of dust in space, and sometimes the walls of cameras like Hubble can't be broken through. Scientists still don't know what was hidden behind them. Infrared light can get through dust clouds, which is how Webb was able to make pictures from these light trails. This is how we can now see parts of the world that Hubble couldn't see. Hubble found the galaxy NGC 1277, which is about 220 million light-years from Earth. This was a big step forward in space research. Even though it has some problems, this galaxy is another live fossil from when the universe was young. All of the stars in NGC 1277 are very old. Imagine a galaxy that is mostly made up of very old stars. These stars are beautiful in their shape and function, but they haven't changed much in billions of years. More than half of the stars in this galaxy are between 10 and 12 billion years old. At this point, these stars are still a long way from dying out. In comparison, the Sun probably only has about 9 billion years left in it. It's odd that this galaxy has created so many stars that will last a very long time. Scientists want to know how galaxies turned into such beautiful, starry structures so quickly, and they want to know if this is how all galaxies in the early universe formed. At the moment, the starburst theory is the most accepted way to explain why Webb's galaxies are so old and well-developed. Around 200 or 300 million years after the Big Bang, there may have already been thousands of beautiful, very advanced galaxies in the universe because of rapid growth. Unlike fossil galaxies, normal galaxies have changed over time since the beginning of time. Stars were born and died, and galaxies moved and joined with others, making them look and feel different each time. NGC 1277, on the other hand, hasn't made any new stars in a very long time. The galaxy is mostly made up of old stars that don't have much metal in them, which is typical of the early universe. Up until now, though, scientists thought that these old stars from the first groups didn't live very long. These early stars that are light, lack metal, and are in the galaxy NGC 1277 are very stable and get to be very old. There may have been an unknown mechanism that stopped the processes in the galaxy from moving. It would be very important for us to figure out exactly what this process is. A force that first explodes whole galaxies into growth, then freezes them, and lets them stay in the shape they took on could reveal a size in the universe that we didn't know about. In an interesting twist, NGC 1277 has a black hole in the middle that is so massive that it makes up about 14% of the galaxy's overall mass. Already, this mass fraction is very high, and there are other strange things going on around this black hole. Most of the time, it would take billions of years for this black hole to eat up all of the galaxy's mass. Because of this, the galaxy would get smaller, especially if it doesn't make any more stars. At this point, we don't know if the black hole in this galaxy has stopped working in some way. Also, NGC 1277 is not in the middle of a huge group of galaxies. Unlike other ancient galaxies, it is mostly by itself and a part of the universe with few other galaxies. A Einstein ring? Have you heard of it? It was long thought that these astronomical things might exist. Albert Einstein, a mathematician, pretty much predicted that these things would exist, but no one has seen one in almost 100 years. To put it simply, Einstein rings are a type of gravity lensing, but they don't make a circle like a magnifying glass. Instead, they make a perfect ring. The James Webb Space Telescope has now found a galaxy with one of these objects. It is called SDSS-J 1226+2149. It's one of those rare scientific discoveries that can only be made possible by the superpowers of the new telescope. The weak signals from this natural wonder in the depths of space could only be picked up by James Webb's good sensors. When the galaxy sent out light, it warped it, making the Einstein ring around SDSS-J 1226+2149. Light is stretched into the shape of a ring by the mass of a galaxy cluster in the way it has twisted and stretched it. Not only is the stretching an interesting physical effect in this case, it also makes things behind it much bigger. In this way, an Einstein ring works like a gravity lens. Researchers can see things that are very far away and almost unnoticeable to the naked eye because of these two effects. The first Einstein ring to be seen was in the galaxy cluster AEL 370, before these effects were known. This cluster even has one of the most beautiful examples of a full Einstein ring that has ever been seen. Astronomers could look at the faraway galaxy in great detail and learn about its structure and the rate at which stars are being born in it because of this effect. The Einstein ring around AEL 370 is not only a fantastic feature, but it is also a great example of how the general theory of relativity works in real life and continues to lead to new finds in astronomy. Astronomers have been able to see many more things in the world thanks to gravitational lensing. One of these things is the galaxy GN-Z11, which is one of the oldest and farthest away galaxies ever found. It will be written in the history books of science. It is about 13.4 billion light-years away and was formed not long after the Big Bang, about 400 million years ago. Astronomers were able to learn a lot about this galaxy's structure and make up thanks to the lens effect, which made the light from it brighter. Gravitational lensing allowed even the Hubble Space Telescope to make this finding, even though scientists thought it was past its useful life. Gravitational lensing was also used to find Max J1149+2223 Lens Star 1, which is the farthest single star ever seen. The star is in a galaxy that is about 9 billion light-years away. Because of the gravitational lensing effect of a group of galaxies between Earth and the star, the light from this star would be too weak to be seen at all. The gravitational lens made the light about 1,000 times brighter, which let scientists study a single star from so far away in great detail for the first time. Scientists really enjoy finding single stars from very long ago. We can now break with the help of the James Webb Space Telescope. Light signals from stars like MAX J1149 plus 2223 can be broken down into their constituent parts. This lets scientists quickly get accurate studies of the gases and elements that made up the stars in the early universe.